Day 2, Problem 1. Part A. Identify the x-intercept and y-intercept for the graph of this linear equation. Let's start with the x-intercept. The x-intercept is a dot on the x-axis. And because it is on the x-axis, its y-coordinate is 0. And so we can find the x-intercept by substituting 0 for the letter y. That will create an equation that still has the variable x in it, but no longer has the variable y. 4 times 0 is 0, and that's equal to 2x minus 6. Let's solve this equation. We could do our typical working backward steps to solve this. Add 6, and continue on. Or we could just try to solve it mentally, whatever you are more comfortable with. If this is 0, and I want to discover what x is, how about 2 times 3, and then take away 6? That would be 0. And so I can figure out that x must equal 3. As an ordered pair, the x-intercept is 3, 0. Now for the y-intercept. The y-intercept is a dot on the y-axis, and because it's on the y-axis, its x-coordinate must be 0. And so I can find the y-intercept by taking the original equation and substituting a 0 for the variable x. That creates this equation. It still has the letter y in it, but it no longer has the variable x. And working this out, this is 4y equals 2 times 0 is 0, subtract 6 is negative 6. And then dividing both sides by 4, we would get y equals negative 6 over 4, which reduces to negative 3/2, which as a decimal is negative 1.5. So as a ordered pair, the y-intercept is 0, negative 1.5. We can use the x-intercept and the y-intercept to do part B of the question. So to graph the equation, let's begin by putting a dot on the x-intercept at 3, 0. That is here. And we'll put a dot at the y-intercept, 0, negative 1.5. That is here. Through these two dots, draw a straight line. Now, Day 2, Problem 2. The height of a plant, h of x, is a function of the time it's been in the ground, x, in weeks. A plant was 4 inches tall when put in the ground, and it grows 2 inches per week. Part A, write a function equation for this situation. So the situation involves the height of a plant changing based upon how much or how long it's been in the ground. And we can write an equation by using the symbols and numbers provided to us. So first of all, the symbol h of x represents the phrase height of the plant. And so height of the plant is equal to. Now we're told when the plant is first put in the ground that it is already 4 inches tall. And so 4 plus. We're also told it grows 2 inches each week. And we're told to use the variable x to count how many weeks are going by. And so 2 inches per week could be written in symbols as 2x. So this equation, h of x, is equal to 4 plus 2x, is a function equation for the situation. Now in Part B, we can make use of this equation to find the height of plants for 3 weeks and 5 weeks and 12 weeks. It would look like this. h of 3 equals 4 plus 2 times 3. And working this out, 2 times 3 is 6, 4 plus 6 is 10. So the height of a plant after 3 weeks of growing is 10 inches. The purpose of function notation is to be able to show us a height but kind of at the same time show us what number of weeks that height was based on. Okay. Now we can find the height of a plant after 5 weeks of growing. It will be 4 plus 2 times 5. And working this out, this is 14 inches. And finally, we need to know the height of a plant after growing 12 weeks. It is 4 for its initial height plus its rate of change of 2 times 12 weeks of growth. And 2 times 12 is 24. 4 plus 24 is 28 inches tall. So function notation gives us very useful information. It can be used to show relationships between two things, in this case the height of a plant based upon how many weeks it's been growing. And that equation in turn can show us a total height based on a certain number filled in for one of the variables.